Okay, this is quiz 3. The first question says, consider the function f of x is equal to x for x less than negative 2, and f of x is equal to b times x squared for x is greater than or equal to negative 2. They ask for what values of b is this function continuous at x equals, and this was incorrect, should be x equals negative 2. Now notice what they're asking is how can we make this this function connect, essentially. So if we imagine this x for x is less than negative 2, this is just our normal line, but it's stopping at negative 2. Now, we also have this b times x squared. Now, x squared, that's just a parabola, but we're able to control whether it opens up or down and how steep the slope is. So we know, not only do we know that we don't want it to open upwards like our normal x squared does, we want it to open downwards, but we also don't want it to open we don't want it like our normal negative x squared either. We need to figure out what b has to be so that b times negative 2 squared is equal to negative 2. Notice that's what needs to happen for this to be continuous. We need both of these sections of our function to come to the same point. Okay, so now we just have a simple equation to solve. So here we have 4b is equal to negative 2, so that tells us that b is equal to negative 1/2. Okay, so now if we sketch our function, notice it's actually going to open downward and kind of like less steep than our normal x squared function does, like that. Okay, so that is a sketch of this function with your chosen value. If b equals negative 1/2. Now they ask, if b equals 1, does the limit as x goes to negative 2 of f of x exist? Okay, well, I always draw a picture just to help myself out. If I do that, I have this portion of the function, f of x equals x, stays the same. And then if we sketch x squared for b times x squared is just 1 times x squared, so that's x squared. Then up here I have 4, and we come down like our normal parabola, and then over here we just open upwards like this. And now they say, does the limit as f of x approaches, as x approaches negative 2, does the limit of that function exist? It clearly doesn't. Here is negative 2, and notice that from the left-hand side we're going to negative 2, and from the right-hand side we're going to 4. Okay, so the correct answer is no. Now, if b equals 1/2, does the limit exist? Well, notice we've already kind of drawn this picture, and it's going to remain mostly the same. Here we've got still this line, and then this, all that happens is it kind of flattens out our parabola curve. So instead of going up to 4, we're actually just going to be kind of a smoother curve like this, and this is going to go up to 2, and then this is going to go down to negative 2, and this just continues on. So again, they asked, does the limit as x approaches negative 2 of f of x exist? No, it still does not exist. The right-hand side limit and the left-hand side limit don't match up. Okay, if b equals 3, which of the one-sided limits exist, and what are their values when they do? Okay, if we sketch this function now, we're getting to be pretty much a pro at this. So if we draw the section of the function that stays the same, and then notice if b equals 3, then the other section of the function is 3x squared. Okay, so if we go over here to negative 2, we are actually up at 12. So this is an even steeper parabola. So it looks something like that. Now, which of the one-sided limits exist? So as x approaches negative 2 from the positive side, we're approaching 12. So that exists. Now, as x approaches negative 2 from the negative side, we're approaching negative 2. So that also exists. So both of these, in fact, exist. And the limit as x approaches negative 2 from the positive side is 12, right? We're following the 3, f of x equals 3x squared up to 12, and then over here, as x approaches negative 2 from the negative side, we're following x to negative 2.